Good afternoon, everyone. Today we will be discussing the first reactions of organic chemistry. Usually when we have a carbon with an electronegative group, such as an alkyl iodide, this bond tends to be polarized in that direction, which makes the carbon have a partial positive charge and the leaving group have a partial negative charge. If you include another molecule, say hydroxide, this hydroxide can be attracted to the partial positive charge of carbon and attack. But carbon, since it's sp3 hybridized, has to let go of a bond. And it will let go of the most electronegative bond, which is the one with alkyl iodide. The result is that now we have carbon bonded with the hydroxide and iodine as a separate entity. This is called a nucleophilic substitution, and we abbreviate it like this, like substitución nucleophilica. When you study the rates of reactions, if you double the amount of the substrate, the reaction is twice as fast. And I am calling the substrate R for now. If you double the rate of the nucleophile, the concentration of the nucleophile, the rate also doubles. Because the rate of reaction depends both on the substrate and on the nucleophile, this reaction is called a bimolecular reaction, or in Spanish, sustitución nucleofílica bimolecular. Now notice that everything is happening at once. The nucleophile attacks the carbon and the leaving group leaves at the same time. This is called a concerted reaction. Now, if we study the progress of the reaction, and let's call this the energy associated with this reaction, as your nucleophile approaches the carbon, this bond starts to break. At its highest point, once the reaction reaches the activation energy it needs, the iodide bond, or the bond with the leaving group, is almost broken. While the bond with the nucleophile is starting to form. This is the transition state of this reaction. The point at which this is almost broken and this is formed, that's when you get to the activation energy of the reaction. And once you reach this point, the reaction goes into completion to reach the product. Now, there are several parameters that we need to look after when we are studying the SN2 reaction. One of the most important has to do with the substrate, and the substrate is the combination of the alkyl group and the leaving group. We also need to study the nucleophile, because only certain nucleophiles can do an SN2 reaction. And because these reactions don't happen in a vacuum, we also need to study what solvent we do the reaction in. So the first thing that we're going to study, the first parameter that we're going to study is the substrate. Within the substrate, we're going to study the carbon first. This carbon that I drew is a methyl. It is a CH3. It's the carbon that has the least possible steric hindrance. But carbons come in all shapes and sizes. Now let's look at the transition state of this reaction. At any given point, the leaving group is leaving, and the nucleophile has to approach the back of this carbon in what is called a backside attack. Because of this backside attack happening at the same time as the leaving group is leaving, the carbon takes this form, this transition state, where anything that is too big will affect it. So we need to look at those three groups on the carbon at the transition state. With hydrogens, there's not a big deal because hydrogens are small. There's no steric hindrance involved. There's nothing preventing attack to the carbon. If we change one of these to a carbon, and let's do a CH3, there's still enough space for the nucleophile to approach this carbon. So primary carbons can react by SN2 mechanisms. If we replace a second carbon, a second hydrogen with another carbon, this becomes secondary. And although there's more carbons are bigger, think of the carbon as having these three hydrogens, or who knows how large the other groups are, they start to block the back face of this carbon that we want to attack. So we may be in a little trouble, but we can still approach it because there's still a hydrogen left. So depending on the right conditions, secondary carbons can also do SN2 reactions. However, if we replace all three hydrogens and we have carbons on all three sides, this carbon becomes too hindered for an SN2 reaction, for a backside attack to happen. And therefore, tertiary carbons do not undergo SN2 reactions. They can react, just not through the SN2 mechanism. Okay? The other aspect that we need to look at is the leaving group on this reaction. And leaving groups will need some very specific conditions for them to be efficient in an SN2 reaction. The first step, the leaving group needs to be electron withdrawing. Because A, you want this carbon to be partially positive, and B, you want the leaving group to take away the electrons. In order for the leaving group to take away the electrons, it needs to be stable once it goes away with the electrons. So it needs to be a weak base. Remember, weak bases are stable bases, and stable bases do not react. You want a stable product for this reaction to happen. So I'll give you a few examples of good leaving groups. The halides, such as iodide and chloride and bromide, are examples of good leaving groups. These are the conjugated bases of some of the strongest acids that you know, and therefore they will be stable leaving groups. Neutral molecules, such as water or alcohols, are also very good leaving groups. These are neutral molecules. They tend to not react. They will react, but not just not the way we want them to. Now, let me give you an example of a poor leaving group. Poor leaving groups are, for example, hydroxide. Hydroxide is a very strong base. It doesn't want to be on the product side because it wants to react back. The same thing with any alkoxide. Alkoxides don't want to be products. They want to react and be more stable. Finally, fluoride is an alkyl. It's a halide, But fluoride is also the most electronegative ion that we know. It wants to hold those electrons very tight, and it does not want to leave the carbon once it's attached to it. So fluoride is an example of a very poor leaving group.